All right, guys, so let's talk about reflections across other lines. If we reflect across the line y equals 1, okay, first of all, y equals 1 is this horizontal line right here. Okay, and we are just going to use the counting technique, right? A is 2 units away, so A prime will be 2 units away on this side. B is 1 unit away, so B prime will be 1 unit away on the other side. Okay, reflecting over the line x equals 1. Okay, x equals 1 is a vertical line. So A is 1 unit away in this direction, so A prime will be 1 unit away on the other side. B is 1, 2, 3 units away, so 1, 2, 3 units away on the other side, and then make your connection. Okay, when you rotate around a point other than 0, 0, the rules do not work, or the rules do not apply. So we're going to have to get a little bit creative, and what we're going to do is we're going to force the center of rotation to become 0, 0. So 2, 1, right? They're saying that's the center of rotation. Well, if we want that to be our center of rotation, okay, we're going to force that to be, oops, sorry about that. So to be our 0, 0. So I'm going to draw my y-axis through there and my x-axis through there. Okay, now that I've redrawn this, we're going to talk about what the location of A is if you were to consider this to be your new origin, right? That means A is 0, 2, and that means B is at, let's see, 1, 2, 3, 4, 1. Well, rotating 180 degrees, as a reminder, the rule for rotating 180 degrees in any direction, okay, is that your x is negated and your y is negated, or they change signs. So our A prime is going to be 0, negative 2. Our B prime is going to become 4, negative 1. Now, when you plot these, you need to plot them based on your new origin. So 0, negative 2, and then 4, negative 1. And then make your connection. Okay, for this one, we're going to start with making our origin negative 1, 2. So you're going to redraw your y-axis and your x-axis through your new center of rotation. Okay, that means our A, if that's your 0, 0, A is at 1, 2, 3, 1. And your B is at negative 1, 0. Okay, the rule for 90 degrees clockwise is x, y goes to, let's see, clockwise would be y negative x. Okay, so let's apply the rule. Bring y to the front, x to the back, and change the sign. Bring y to the front, x to the back, and change the sign. Now just make sure that you plot those based off of your new origin. So start here, over 1, down 3. And let's see, over none and up 1. And then make your connection. Okay. Dilating from points other than 0, 0, we could use the same strategy if we wanted to. I'm going to force that to become my new 0, 0, so 2, negative 3. All right, once I force that to become my new origin, okay, A is now technically located at, let's see, 1, 2, 3, 4, 5, 6, 0, 6. Your B is located at 1, 2, 3, 4, negative 4, 2, 3, 4, 5. Okay, and then dilating by a scale factor of 1/2 means we're literally just going to multiply these by 1/2. 0 times anything is 0. Half of 6 is 3. So there's your A prime. Your B prime, half of negative 4 is negative 2. Half of 5 is 2.5. Now when you plot it based off of your new origin. So 0, 3, 1, 2, 3. Here's your A prime. Negative 2, 1, 2, 2.5. Here is your B prime. So notice it's half the size and it's halfway closer to the center of dilation. Okay, let's try this one more time. around 0, 3. So 0, 3. Here's your new x and your y. Okay, which means that A is currently at, let's see, 2, 0. Your B is at -2, -1. Okay, the scale factor is multiplying by 2. So if I multiply these by 2, we get 4, 0. If I multiply these by 2, I get -4, -2. And then just make sure you plot these based off of your new origin. So let's see, over 4, back 4, down 2. Okay, notice it's twice as big and it's twice as far from the center of dilation. Okay, last topic that we're going to discuss is mapping a figure onto itself. If we were to talk about reflections for this guy, it is a square, right? So it has some unique lines of reflections. If you were to reflect it across this line, it would map on top of itself, and that line is x equals 1. So a reflection across this line would map it onto itself. Also, a reflection across the x-axis would map it onto itself. So you could say x-axis, or the equation for the x-axis is y equals 0. Right? So those lines of reflections would allow it to map onto itself. So we have 2 options. All right, then let's talk about some rotation options. If you were going to rotate it, you need to rotate it around the center of the figure, right? That's the direct middle. So we could talk about rotations about the point 1, 0. And there's a few different rotations that would work because this is a regular polygon, right? It's a 4-sided figure where all the sides and the angles are the same. We can take a rotation of 360 and divide it by the 4 sides. That means any increment of 90 would make this map onto itself. If you rotated this 90 degrees clockwise, this point would rotate onto that point, right? The whole figure would map back onto itself. But then you could also do another 90-degree rotation, another 90-degree rotation, until you work your way all the way back to 360. So rotations about 1, 0, 90 degrees, 180 degrees, 270 degrees, all up to 360 degrees. So all of those rotations would map a figure onto itself. One big takeaway is that if it were to be like a regular polygon or a regular hexagon or a regular pentagon, right, we're going to do 360 divided by the number of sides, right? That would tell you all the different angles of rotation that would map it onto itself if it is a regular polygon. So like a regular hexagon, regular pentagon, a regular quadrilateral, right? A 4-sided figure would be a square. But keep that in mind when you're thinking about angles of rotation.